This line chart shows Nvidia's quarterly revenue over the last 12 years. In 2014, their data center business made up roughly 5% of their total sales. Today, that segment has grown 1,300-fold, pulling in over $75 billion a quarter and consuming 90. If a competitor is selling a cheaper engine that generates the exact same horsepower, why are the world's largest tech companies still willingly handing Nvidia hundreds of billions of dollars? The answer is that the AI war isn't actually being fought over a single piece of silicon. It's being fought over an invisible, three-layer technological stack that Nvidia has been quietly building for 20 years. Deep learning, the math behind modern AI, requires processing vast amounts of data at the exact same time, rather than one step after another. This is known as parallel processing. Traditional central processing units, or CPUs, are incredibly fast, but they handle tasks sequentially. Graphics processing units, or GPUs, operate differently. They contain thousands of smaller cores designed specifically to execute multiple calculations simultaneously. Nvidia stored it as a video game graphics company rendering pixels, but they realized their GPU architecture was perfectly suited for AI math. This became undeniable in 2012, when researchers used Nvidia GPUs to drastically accelerate an image recognition model called AlexNet, proving that raw compute power could force breakthroughs in artificial intelligence. Nvidia mastered this physical silicon layer first, but raw hardware specifications can eventually be reverse-engineered and copied. The chip itself is not what protects their absolute market dominance today. The real barrier to entry is the invisible middle layer, CUDA. This is Nvidia's proprietary software platform that allows developers to write general computing instructions for those GPUs. In 2006, CEO Jensen Huang made a massive bet on this software. For 6 years, the CUDA project drained hundreds of millions of dollars annually, facing severe skepticism from investors and causing intense internal debate about the company's direction. That financial pain bought an ecosystem. By subsidizing research and providing the tools for free, CUDA became the native language of AI. It is now utilized by 5.5 million developers globally. This utilization chart reveals the brutal reality for competitors. Raw hardware is practically useless without refined software to direct it. With its mature software ecosystem, Nvidia achieves roughly 93% efficiency in real-world training tasks. AMD's equivalent hardware currently achieves only about 45%. We can see the physical symptom of this software gap directly. Under dense AI workloads, the processing speed of AMD's chips drops by 42% because their software layer isn't yet optimized enough to keep the hardware running at full capacity. Buying a cheaper, theoretically powerful chip becomes a bad investment if software inefficiency completely erases its performance advantage. This dynamic effectively locks developers and corporations deep inside Nvidia's ecosystem. That brings us to the top layer of the stack, networking. Frontier models like ChatGPT are far too large to be trained on a single chip. To build these massive AI systems, you have to physically tether tens of thousands of GPUs together across rows of server racks, forcing them to act as a single, perfectly synchronized brain. Nvidia recognized this scaling problem early and built an $11 billion networking division. They rely on proprietary technologies like NVLink and InfiniBand to ensure these thousands of chips can pass data back and forth with near-zero delay. Nvidia provides the entire nervous system for these clusters, ensuring that data flow never hits a bottleneck as it travels across massive server facilities. For tech giants, this three-layer stack creates extreme switching costs. When your data centers are hardwired with Nvidia networking and your entire engineering team speaks CUDA, leaving that ecosystem is incredibly painful. Attempting to migrate to a cheaper chip like AMD's requires massive software rewrites. In an AI arms race where getting a model to market a month early is a matter of survival, no one wants to sacrifice that development time. But there is a new front emerging that threatens this moat. The industry is beginning to shift its focus from training AI models to actually running them for end users, a process known as inference. This animated scale demonstrates why inference changes the math. While training favors Nvidia's software dominance, the balance tips heavily toward inference. Inference is highly price-sensitive, far less reliant on custom CUDA code, and demands massive memory capacity, the exact metrics where AMD's cheaper hardware excels. The biggest threat going forward might not even be AMD. Hyperscalers like Google and Broadcom are already bypassing the open market entirely, designing and building their own specialized custom silicon specifically tailored for these inference tasks. Nvidia operates as the bedrock ecosystem of the AI era. Their trajectory proves that enduring monopolies aren't won through a single product launch, but by building the entire environment required for a completely new industry to exist.